Hi guys, let's look at the second video of this chapter, remainder and factor theorem. We are on exercise 8a where we talked about remainder and factor theorem. But before we start, let's revise what the remainder and factor theorem is. It says without actually dividing a polynomial. So let's say if fx, which is a factor of x, is a polynomial, right? And it is polynomial is divided by, you're dividing it by x minus a. Without actually dividing, you can figure out the remainder. The remainder will be the value of the polynomial when x is equal to a. So the remainder when the polynomial is divided by x minus a will be equal to the value of the polynomial when x is equal to a, which means if you're dividing x square minus 5x plus 6 by x minus 1, then the remainder will be equal to value of x square minus 5x plus 6 when x is equal to 1, right? X is equal to x minus 1, you're dividing it by, which means x is equal to 1. Now, the what does the factor theorem states? Factor theorem states that when you divide a polynomial by x minus a theoretically, and the remainder is 0, then the x minus a is a factor of the polynomial, which basically is a part of the remainder theorem. In this factor theorem, the remainder is 0. Good, let's go ahead and look at some questions now. So question number 8, it says find value of m and n so that x minus 1 and x plus 2 both are factors of the given polynomial. So using factor theorem, what we have is x minus 1 is equal to 0. This gives us x is equal to 1. Now since x minus 1 is a factor, therefore remainder will be 0, which means f of 1 will be equal to 0. In this case, f of 1, which is equal to 0, will be equal to the value of the polynomial when x is 1. So 1 cube plus 3m plus 1 square plus n into 1 minus 18. This will give us 1 plus 3m plus 1 plus n minus 18 is equal to 0. This is 3m plus n, 3m plus n. That's 1 plus 1, 2, 2 minus 16, that's negative 16. Let's take negative 16 to the other side. So we have 3m plus n is equal to 16. That's my first equation. Again, I guess we'll get another simple equation and we'll have to solve it simultaneously. Next, x plus 2 is equal to 0, which means x is equal to negative 2. Now, since x plus 2 is a factor, therefore the remainder will be 0. So f of negative 2 will be equal to 0. Let's figure out the value of the polynomial when the value of x is negative 2. So f of negative 2, which is equal to 0, is equal to negative 2 cube plus 3m plus 1 multiplied with negative 2 square plus negative 2n, multiplied with negative 2n minus 18. That gives us negative 2 cube, which is negative 8, plus negative 2 square is 4. So that's 4 times 3m plus 1 minus 2n minus 18, and this will be equal to 0. That's negative 8 minus 18, which is negative 26, plus 4 into 3m, that's 12m, plus 4 into 1, 4, minus 2n is equal to 0. This gives us 12m minus 2n. 12m minus 2n, that's negative 26 plus 4, that's negative 22. When I take it on the other side, that's plus 22. I notice all elements have common 2, so let's divide everything by 2, and we get 6m minus n is equal to 11. That's our second equation. So now that we have both our equations, let's go ahead and solve them simultaneously. So we have 6m minus n is equal to 11 and 3m plus n is equal to 16. When I add we get 9m is equal to 27, which means m is equal to 3. Now put m is equal to 3 in equation 1 and we get m is equal to 3, that will be 9 plus n is equal to 16, n is equal to 7. So the value of m and n is equal to 3, 7. Let's see what do they want. Find the value of m and n. We've done it. So let's look at the next question. The next question that we do is question number 11. Question number 11 says, if x cubed plus ax squared plus bx plus 6 has x minus 2 as a factor. Okay, so it has x minus 2 as a factor, which means the remainder will be 0 and leaves a remainder of 3 when divided by x minus 3, which means x minus 3 is not a factor, it leaves a remainder. We need to find the value of a and b. So there are two conditions given. Let's figure out the details for both the conditions. So since it's a factor, which means using factor theorem, what we have is x minus 2 is equal to 0, which means x is equal to 2. Now since x minus 2 is a factor, therefore the remainder will be equal to the value of the polynomial when x is equal to 2. So f2 should be equal to 0. Let's figure out the value of f2. So f2, which should be equal to 0, is equal to x cube, that's 2 cube, plus a times 2 square plus b times 2 plus 6. Now 2 cube, that's 8, 2 square, that's 4a plus 2b plus 6 is equal to 0. That gives us 4a plus 2b, and this is 8 plus 6, which means 14. When let's take it on the other side, so that's negative 14. All elements have 2 common. Let's divide everything by 2, and what we get is 2a plus b is equal to negative 7. That's our first equation. Let's look at the second condition. When the second condition is given, it says when it's divided by x minus 3, there is a remainder, which means using remainder theorem, what we have is point number 8, x minus 3 is equal to 0, which means x is equal to 3. Now since remainder is equal to 3, yes, remainder is 3, therefore the value of the polynomial when x is equal to 3 is also equal to 3. So value of the polynomial when x is equal to 3 is equal to the remainder, in this case 3. So let's find the value of the polynomial when x is equal to 3. That will be 3 cube plus a times 3 square plus b times 3 plus 6, and we know that this will be equal to 3. Let's open this. So that 3 cube, that's 27, plus 9a plus 3b plus 6 is equal to 3. That's 9a plus 3b, and we have 27 plus 6, that's 33. When I take it on the other side, that becomes negative 33. So that 3 minus 33. So this is 9a plus 3b is equal to negative 30. Okay, all of them have 3 common. So let's divide everything by 3. So what we get is 3a plus b is equal to negative 10. And that's our equation number 2. So we have 2 equations. Now we'll have to solve them simultaneously. So I notice that the coefficient of b in both the cases is equal. So let me go ahead and subtract them. So this is 3a plus b is equal to negative 10, and this is 2a plus b is equal to negative 7. Let's subtract, the sign changes. So this becomes 3a minus 2a, that's a, b negative b gets cancelled, negative 10 plus 7, that's negative 3. Therefore a is equal to negative 3. Now put a is equal to negative 3 in, let's say, equation 1. We get 2 into negative 3, that's negative 6 plus b is equal to negative 7. B is equal to negative 1. So a comma b would be equal to negative 3 comma negative 1. Let's read the question. Find the value of a and b. We've done it. So there were two conditions. Till now, the question that we done was both of them were given a factor. In this case, x minus 2 as a factor, which means remainder is 0. And x minus 3 leaves a remainder of 3, which means the value of the polynomial when x is equal to 3 will be 3. Good. Let's look at the next question. The next question that we do is question number 13. Question number 13 says, what number should be added to 3x cubed minus 5x squared plus 6x so that the resulting polynomial is divided by x minus 3, the remainder is 8. Okay, so let k be added. So our resultant polynomial, is equal to 3x cubed minus 5x squared plus 6x plus k. So that's the polynomial that we have. And this is being divided by x minus 3 and there is a remainder of 8. So using remainder theorem, what's given is x minus 3 is equal to 0, which means x is equal to 3. So since the remainder is 8, which means the value of the polynomial when x is equal to 3 will be equal to 8. Yes, since it's being divided by x minus 3, the value of the polynomial when x is equal to 3 will be the remainder, in this case 8. Let's figure out the value. So f of 3, which is be equal to 8, is equal to 3 times 3 cube minus 5 times 3 square plus 6 times 3 plus k. So I've replaced the value of x with 3. So now what this gives me is 3 cube, that's 27 into 3, 81, minus 3 square, 9 into 5, 45, plus 6 into 3, 18, plus k, that should be equal to 8. And that's correct. So 81 plus 18, that's 99. 99 minus 45, that's 54. Yes, 99 minus 45 is 54. So this is 54 plus k is equal to 8, which means k is equal to 8 minus 54. Therefore, k is equal to negative 46. So we will need to add negative 46 to the given polynomial so that when the resulting polynomial is divided by x minus 3, the remainder will be 8. Good. Let's look at the next question. The next question that we do is question number 14. This time it says what number should be subtracted from the given polynomial so that on dividing it by x minus 2, the remainder is 10. Last time we had done adding, this time it is about subtracting. So let k be subtracted. So the polynomial that we get is required polynomial or the resultant polynomial will be equal to x cube plus 3x squared minus 8x plus 14 minus k. Now it's leaving a remainder, which means using remainder theorem, it's being divided by x minus 2, which means x minus 2 is equal to 0, which means x is equal to 2. Now since it's leaving a remainder, the value of the remainder will be equal to the value of the polynomial when x is equal to 2. So f2 is given equal to 10. So the value of the polynomial when x is equal to 2 is the remainder, in this case 10. Let's figure out the value of the polynomial when x is equal to 2. That will be 2 cube plus 3 times 2 square minus 8 times 2 plus 14 minus k. Yes, that's correct. The resulting polynomial is x cubed plus 3x square minus 8x plus 14 minus k. So we have 2 cube, that's 8, 4 into 3, that's plus 12, minus 16 plus 14 minus k is equal to 10. Let's see what we get. What we have here is 8 plus 12, that's 20, 20 plus 14, 34, 34 minus 16, that's 18. Yes, that's 18. So 18 minus k is equal to 10, which means 18 minus 10 is equal to k. Therefore, k is equal to 8, which means we need to subtract 8 from this polynomial so that the resulting polynomial, when it is divided by x minus 2, we'll get a remainder of 10. That brings me to the next question. That's question number 15. It says the polynomial 2x cubed minus 7x squared plus ax minus 6 and the second polynomial x cubed minus 8x squared something something when leave the same remainder when divided by x minus 2. We need to figure out the value of a. What is that remainder? Not given. But both of them leave the same remainder when they are divided by x minus 2. So let's go ahead and look at the first polynomial first. So since they are leaving a remainder, so which means using remainder theorem, what we have is x minus 2 is equal to 0, which means x is equal to 2, which means remainder when 2x cube minus 7x square plus ax minus 6 is divided by x minus 2 is equal to value of polynomial when x is equal to 2. Correct. So let's figure out the value of the polynomial when x is equal to 2. So when x is equal to 2, the value of the polynomial, which is the remainder, will be 2 times 2 cube minus 7 times 2 square plus 2 times a minus 6. In this case, 2 cube, that's 8 into 2, 16, minus 2 into 2, 4, minus multiplied with 7, that's 28, plus 2a minus 6. So this is equal to 2a, 16 minus 6, that's 10, 10 minus 28, that's negative 18. So that's the remainder when the first polynomial is divided by x minus 2. Let's do the same thing for the second polynomial. So using remainder theorem, what we have is point number 6, x minus 2 is equal to 0, which means x is equal to 2. So the value of the polynomial when x is equal to 2 will be equal to, for the second polynomial now we are looking at, so this is 2 cube minus 8 into 2 square plus 2a plus 1 multiplied with 2 minus 16. So that's equal to 2 cube, 8 minus 2 into 2, 4 into 8, 32 plus 4a plus 2 minus 16. 8 plus 2, 10, 10 minus 32, that's negative 22, negative 22 and negative 16, that's negative 38. So this is negative 38 plus 4a. Let's reconfirm. 8 plus 2, 10, 10 minus 32, that's negative 22, negative 22 minus 16, negative 38. So this is equal to 4a minus 38. Now, what is the relation between them? Since both the remainders are equal, therefore we can equate them. So since the remainders are equal, therefore equate first equation and first expression and the second expression. And what we get is 2a minus 18 is equal to 4a minus 38. So that will give us negative 18 plus 38 is equal to 4a minus 2a, which means 2a is equal to 20. Therefore, a is equal to 10. So when the value of a is 10, then both these polynomials, when they are divided by x minus 2, they will leave the same remainder. How much is it? We can figure it out, but that's not the question. They wanted us to figure out the value of a. So that brings me to the last question from this exercise, which is question number 17. It says find a if the two polynomials leave the same remainder when divided by x plus 3. So a similar question using remainder theorem. Point 1, when x plus no, not when x plus 3, we can directly write x plus 3 is equal to 0, which means x is equal to negative 3. So value of the first polynomial when x is equal to negative 3 is the remainder. In this case is equal to remainder, and in this case that will be equal to a times negative 3 cube plus 3 times negative 3 square minus 9, and that will be equal to, that's negative 3 cube, that's negative 27a, plus negative 3 square, that's 9 into 3, 27 minus 9. This is negative 27a plus 18. That's our first equation. This is the remainder when the first polynomial is divided by x plus 3. Let's look at the second one. So using remainder theorem, we have x plus 3 is equal to 0, x is equal to negative 3, which means f of negative 3 will be the remainder, and that will be for the polynomial second will be, let's put the value of x as negative 3. So 2 times negative 3 cube plus 4 times negative 3 plus a, that's negative 3 cube, that's negative 27 into 2, negative 54, plus 4 into negative 3, that's negative 12 plus a, which means remainder is a minus 66. That's our second equation. Now, since the remainders are equal, therefore equate 1 and 2, and what we get is negative 27a plus 18 is equal to a minus 66, which means 18 plus 66 is equal to a plus 27a, that's 70, 84 is equal to 28a, therefore a is equal to 3. Perfect. Similar question to the last one. That brings me to an end of this video. I have marked some homework questions for you. Take care, be safe. If you have any queries or doubts, feel free to write into me. Bye bye.